Hello everyone and welcome to Microcontroller 101. This is a beginner's tutorial to microcontrollers, how to use them, how to program them, some tips, tricks, all kinds of information you're going to find here. If you are an intermediate or experienced player, this probably is not for you, but if you're looking at this thing and wondering what on earth do I do with it, then I think you should follow along. So this actually comes because some people had been telling me that I should just make tutorial videos with simple logic. So just like this, where you have kind of function gates or addition gates, whatever, and or functions, whatnot. Now, microcontrollers are that and much more. They end up being quite advanced. Now, yes, you can make a bunch of these that you can probably follow along in the in-game logic, but there is too many advantages to just doing the microcontroller properly. So I'm going to go through what these menus are, how to make them work, give you a full breakdown, and hopefully you can walk away knowing something more about microcontrollers than when you started off. I'm going to quickly explain the purpose of microcontrollers, what they are. So as you know, hopefully, the game is based on logic inputs and logic outputs. Logic being the system that transmits information. So there are two types of logic. You have on-off, which is also called Boolean in coding talk, but considered on-off for us in this video, and number. On-off is red, number is green. So for something like a dial, if we spawn that in here, we go to the logic node here, and you can see we have a backlight, which is an on-off, and we have a dial, which is a number. Now this doesn't do anything unless you attach something to it to display said number. So if we put a thermometer or temperature probe and connect this, well, now that display will be showing what this is outputting pretty much. And you can also put a push button, or better yet a toggle button, but doesn't really matter, that is attached to this, and when you press this it will turn on the light. So very simply, this explains the two kind of red and green logic, and that is the fundamental basis of what this is. Now, as I was saying, you can use the pre-built function like this for AND, obviously, and this is something quite simple. If you're having like push this button and push this button and make something turn on or happen or whatnot, obviously I don't disagree with using this. There's OR functions that you can also use. There's XOR, there's memory, there's a lot of stuff here that you could use and basically end up with what the microcontroller has. Now, I'm not going to go into what these pre-built, I'm going to call logic boxes are, but they are the basis of what an microcontroller is. So I'm going to spawn this microcontroller. I just made this one, it's called empty, but pretty much there is nothing going to it. Now, how do you work it? What happens here? You can go into this edit microcontroller and go into this menu, and you see here now you can set a name. So we can name this whatever we want. We can give it a description, and I'm going to teach you some steps that you should follow here that are going to help you down the road. But in essence, you can make your own AND function. So the one we just saw, you can do the same thing here, just like this. And now in here you program them. Now before I dig too deeply into that, because this isn't really the purpose of the video to make an AND function, you already have that. It's just a basic explanation. Now when you go here, you could see that there's on-off, there's number, composite, video, audio. Now in this video we're going to briefly touch on composite, but really it's about the on-off and the number ones. Video and audio I'm not going to bother talking about here because they're a little more advanced, and they do have some elements that once you learn composite you could kind of apply them to these ones. But really it's this and these things, whether it's an input or an output. So that's really important. Now keep in mind this name does not change when you set it to output, so you'd manually have to put it to output, but I recommend putting a proper name. So This now becomes your microcontroller. Of course, you can draw a picture here, and you should put a description of what this thing does. In here, you'll find your logic. Now, this is similar to those boxes that we are putting down, and take a look at the inventory of things we have at our disposal. Before you get overwhelmed with this, there's basically a couple categories to consider. So we got the arithmetic, which is mathematical equations, so addition, clamping, and you could see right here, it's telling us what this does. So these have number inputs, logic outputs, as you could see. Then we have logic, or logical. And you'll notice that now we've gone to the on-off. So we're no longer looking at numbers like this, we're looking at on-off. Keep in mind, some of these do have on-off outputs. So for example, equal will tell us. Now, I'm not going to go through every one of these. You can read this description. You can find on the internet what they do. But pretty much you have arithmetic, logical, then you have control. So this actually does things such as switching signals, timers. Then you have the composite, which also includes Lua script, which is programming. We're not going to go into that in this video. And video switch box and audio switch box. So it allows you to do some composite things. And then we have properties. Now I'm going to get to that later. So that is the fundamental bit of what it looks like at first. I do want to give you a basic example of where you can use them, what type of stuff it can do. So for example, this very simple creation, it has the controls to this front fork. It has these controls, so you see how it can operate this stuff. And of course it has the computer. Now this is the Lua programming part that I talked about. We're not going to go into programming displays here. This is a beginner tutorial. But what it does, or what I've done, is here you could see we have a very simple microcontroller for the fork tilter. Now, yeah, it looks a little intense, but the point of this is pretty much to tilt the forks forward or backward based on what you've pressed. There's a bit more of an intricate microcontroller here that actually controls the whole thing, and this is something I've developed over some time. So you can see it has the brakes, it has the acceleration, it has the lifting of the fork, and over here is the display. Again, don't expect you to know this, just showing you this is kind of what you do with microcontrollers if you're not familiar with the logic of the game. Now, yeah, you kind of have to dig through here. I always recommend using the free mode camera instead of the orbit, but pretty much you can hold shift and it kind of slows down your camera, and you can move around until you've taken these and plugged them into wherever they need to go. So the AND functions, OR functions, XOR, NOR, things like that, to me are pretty self-explanatory. Addition, division, constant number, constant on, those are pretty self-explanatory as well. So you have an arsenal here at your disposal of things that you can do. Now we also have functions, so you have the ability to take whatever's coming in, this is X, Y, Z, and pretty much apply an equation to it. So X multiplied by Y divided by Z, whatever. You just have to make sure you type it right, but pretty much you have the ability to do that. You have other ones where it is a Boolean, so where you can have the combination of things that are on off controlling what happens here. So now you have less, like it is kind of an equation, but not really addition and multiplication. Rather, you can do a series of things like this. One of my favorites is the numerical switch box. You have two numbers coming in, you have a switch signal, and one number coming out. So where is this useful? Well, there's a lot of applications for this, but pretty much with something like this, you'd want to have an input button. And once we find it here, this always spawns the center, by the way. So if you're ever lost, you just find kind of where the center is, and that's where this is. So you have now a button going to this, and let's say this is going to the throttle of an engine. Now I'm not going to show you how to make an engine microcontroller. I have that video that I've already made. I'm just going to show you something basic here. So you have your input, you have this going to your engine throttle, And you could have, for example, let's imagine the engine's already running. So what you can do is now have a constant number here and a constant number here. So let's call this where the off function is. So if this is off, let's make this 10% or 0.1. If it's on, we can make it like 0.6. So what happens is, say the engine's running, it's on the off because we didn't press this button. So if we want to turn it up, like make it high output or make the engine rev up louder, we put this, and now it's going to throttle to 60% rather than 10. So you can do that, but you're not limited by obviously the constant number. You can put another block like this with a number input. So now in this case, and this is probably the most basic on throttle function you could think of, is this input here is the ignition, and you turn on your engine and it's now being controlled by a lever. This is your lever. You turn off the engine, it goes to 0. You don't have to put a constant number of 0 like that. You're good to just leave it empty. That is 0. So that's your super basic way to have a numerical switch box. Tons of uses for this one. Now remember when I said that down here we have these properties? Well, I'm going to talk about that now. So property slider, you can actually, instead of this input here, we'll remove that, you can have this there, and this allows you to set some numbers. So let's say a max of 1, minimum of 0, rounding of 0.1, and starting value of 0.5. Now if you spawn this in the game, you end up with a little lever here. So this allows you quick changes on your microcontroller without having to enter it and tweak your constant number. Like if this was your constant number, you'd have to go here to change it, 0.2. You trial and error, come back in here, 0.4. No, this way you just change it up there. Now this is a nice thing, the slider, but you can also do property number. So this is the same thing, except now it actually just allows you to put whatever number. The downside of this is you could put a stupid number like that does not work for your system. Maybe you're limited from 0 to 1, and now you've put this, and obviously that's going to consider it like 1, but the slider gives you a little bit more control, especially if you're making controllers that others are going to use. Now there's other things here like tooltip number and tooltip on off. This is fantastic for troubleshooting. So what you do is you plug this into there, and you can have it always displayed, or you can select if you want it to only display if there's an error. But pretty much what this does, and the other one, which is a tooltip on off, what this does is it will, in your actual microcontroller here, tell you whether or not you are doing said things. So now you see value 0, values off. Now if you press it, it just lets you to troubleshoot it. You can hover over things like this and see what's going on in your microcontroller. So that's a good way to troubleshoot things if something you don't want to happen is happening. If things aren't working, you can see why maybe something like, obviously this is a small, very simple, but imagine you have a huge code. You could put this here and attach it to something and see like, why didn't this get triggered? Maybe the microcontroller thinks the engine's off. So you plug it into like an engine on node and it'll tell you. Another useful one is the numerical junction. Now this is not really like the numerical switch box, because what this does is actually one number comes in, and depending on our signal, there's an on path and an off path. So it doesn't switch this one like that, but rather it will apply some things to something else. So just a quick example, numerical switch box is how you'd make a pivot work for landing gear, for example. You'd set your off is 0, meaning the landing gear did not extend. Whereas when you press the button, we'd set this maybe to 1, because that's the angle that the rotation pivot uses. So and this would obviously go to the pivot of the landing gear. So that's how this would work. You have one node going to one thing. The numerical junction's different because you're not switching a value that goes to 1 input, you're changing something up that goes to here. Now, that can still be used in a similar way. You'd have your pass through, and if it's on, this happens. So like this. And in essence, now what's happening is if this is off, then this number is not getting through to this. Whereas if it's on, this number is getting through to this. So you could have a second number output here and have that down there. And then pretty much based on where you want something to go. And again, I can't just pull an example out for this one in particular, but really you do want to find things that can apply. I definitely use numerical switch boxes way more, so keep that in mind. I don't think I've really used many numerical junctions just because the switch box provides me with what I need for 99% of the time. The famous PID. Now this is something that is a little more advanced, and I might make a video how to tune your PID, but pretty much what this does is it will have a set point function and it will have a process variable. This is just the on off. Now, the set point is what you've set your PID to. The process is what it's trying to understand. So I'm not going to explain how to do it in this one. We're just giving you a basic overview. But imagine you had an altimeter and you had a keypad. So your altimeter will tell the helicopter where you're at. The keypad is where you want to be at. And inside this, you'd put the keyboard to the set point, which is where you want to go. You'd put your actual altitude meter to the process variable, and you'd turn this on when you want to say send helicopter to height or to elevation. And this would now go to your collective. These numbers here do require some fine tuning, and there's a way to do it. I'm not really going to go too crazy on it in this video. I'm just going to say start off with something like this, 100, and see what happens. If it reacts too fast, start dropping this down, go to maybe 0.1, and then you'll see. Now if it's doing the opposite of what you want, throw a negative in front, and then you can change these numbers. But generally I think something like that, depending on what you're trying to do, probably a decent starting point, and then you'll kind of see. But these numbers I'm going to explain in a different video. PIDs have a ton of uses. You can use them for altitude hold, for depth hold for submarines, throttle regulation, gimbal stability for like a camera or turret. There is a second advanced PID, which is the same thing. The only difference is instead of entering here and pressing these values, you have them here for you. So in addition to the set point and process, which you have here and here, you actually have the gain, proportional gain, integral gain, and derivative gain. So what I would recommend, to be honest, if you're starting off and you want to fine tune something really nicely, is what I just showed you here. You'd go to the property number and you'd throw them into each of these. So you'd put 3 of them, and you'd attach 1 to the proportional, 1 to integral, and 1 to the derivative, and then obviously label them, and it allows you to quickly adjust the PID here so you can troubleshoot and quickly change what you're working on. Alongside PIDs, a really useful one is the memory function, because what the memory register does is it actually memorizes a stored number. So what you do is when you hit, now this isn't ignition anymore, this would probably be a push button. So what you do is you push button to set it, and whatever this is here, this now stores that number. So for example, we'd have something like our input altitude, for example. And what you do is now this is how you'd make an altitude hold, by the way, folks. You'd have a number you want to store, you hit hold altitude, and now it's saved in here, and this is what becomes your set point, not your keypad. So only difference is you set it on a keypad versus you just want to stay where you already are. Of course, this would go to your collective. I will show this in another video, don't worry. This is just the very basic introduction and showing you how to use the memory register. Now you have to use a reset. A simple way to do it is, instead of having this be a push, this would be a toggle, and you'd have it be not. So if this is not toggled, this thing is reset. But this isn't enough, because what's going to happen is this is going to be resetting 100 times. Imagine like clicking like boom, 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 boom. That's just resetting, resetting, resetting. So if you do want, you'd have to have a numerical switch box, and this would actually go to the on. And when you turn on your hold altitude, this triggers on and goes here, versus this would be to your seat. So something like that. This numerical switch box really always allows you to turn on and off functions, make sure that a clean number is coming through or 0. So it just really allows you to regulate what you're putting out to this. Anyway, that is the memory register, a very good one. Another very good one is a counter. Counter function works kind of like a lever. So the lever in the game where you press and hold and move the lever physically, this is a very similar thing. This allows you to limit something like between 1 and 0. You can change the increment of how fast. So this is the sensitivity, if you know the lever, and this is the reset number. Now you don't need to have anything resetting it, and you could simply put a button. You hold a button, a push button specifically, to go up, hold another push button to go down, and this is what's coming out. So now you've just made a lever without using a lever. I'm just going to touch on it. We talked about Lua coding, the monitors, displays. So in this case, you have video in, video out, and edit script. You have actual computer coding, Lua coding. It does give you some examples here, but this is more advanced. And probably if you're watching this video to learn how these things work, Lua coding is the next level. I wouldn't even bother thinking about it now. Two similar but different useful functions is the JK flip-flop and the SR latch. How these work, pretty much you set them and then you can reset them. And based on if they're set, it outputs or not outputs. Sounds a bit confusing, but pretty much what you do is, most likely you'd have a push button, and that push button would trigger your JK flip-flop or your SR latch. In essence, it turns a toggle into, or a push button into a toggle. Now, to disable it, you do have to do a little bit of finessing. You'd put, for example, a AND function. So if this is already triggered and you're pressing it again, well, then disable it. And of course, this part here would go to our output, whether it's a light or whether it's whatever, like that. And that's how you'd get the JK flip-flop working. I would probably still put a pulse. Now, pulse is a very useful function because it allows a toggle to be a push. But here's the thing. If you have a push button, but you hold it, like say you hold it for 3 seconds, you're pretty much pounding on the keyboard for 3 seconds, set, boom, 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 set, 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 set. So what this does is, even if you hold it for 2 seconds, 3 seconds, your push button, it will only send one pulse, boom, instant signal to this, and here you go. So it doesn't like do a weird kind of like constant triggering. JK flip-flop and SR latch, for you in this video, very similar. I will talk about the differences in another video, but in essence, it allows you to trigger something. Where I really like this, I wouldn't use this for a light, for example, but it is nice to be able to convert a push function to a toggle function. Now we do have something else here, and it is literally called push to toggle. I have a problem with this one though, because for me, a push to toggle, I can't really keep track of where and when I've turned it on or turned it off. You kind of have to almost really be paying attention. And to be honest, I'd probably still join this push to toggle with a pulse function funny enough, because then, like I said, if you hold it for 2 or 3 seconds, it only sends one signal to this and there to the light. So you can do this top one. The only problem, like I said, is you can't keep track of when it's on or off. In this instance, it would be fine, but where I'm talking about specifically is if you're doing something a little more complex, it wouldn't be when you press this button again. Or maybe it would be if you press this button again, or, all right, now we're getting fancy, or if you do something else. So, or if, let's say, our altitude is greater than something. So now it's triggered by if you press the button again, or if something else happens. Where you can really nicely do this is a threshold function. So threshold will convert numbers into on or off. And you can do that with greater than function or less than function or the equal function. Those all allow you to convert numbers into Boolean or on-offs. Where I like threshold is it's very, very simple and you can set it. Where threshold doesn't work well is if you have two variables, meaning if two things are constantly changing. If you're just going to set this to greater than and set a constant number, like if it's greater than 5, or if this is greater than 5, then this rings true, then you can just go here and just set the low here to be 5 and the high to be like 9999, whatever. And now that's pretty much the same thing. But like I said, if you have two variables, then this becomes very useful. Equals allows you to have kind of a delta between them. So if you put 0.1, there's less sensitivity. If you put a bunch of zeros, now it's very sensitive. So now the equals, it has to be very, very close in order for it to be triggered. So again, this is where JK flip-flop, in my opinion, is better than a simple push to toggle button, because now you can control when you've reset it. Threshold, absolutely instrumental. This one is so useful for all kinds of things where you have numbers. Basically how you'd make a bilge pump for a ship would be a threshold gate, and you'd pretty much just say, well, hey, if my water, you'd set this to your water meter. If your water is between, let's go 1 and like infinity, well, turn my bilge pump on. Boom. That is all you need for a bilge pump. Now, mine personally is a little more complex because also now I've added a button. So I've said, let's do this, but now if I've pressed the button, let's not do it. So how you can do that? You can put either have this going through here with an input. Now, if we put and, that would imply now that if the button is pressed and it's filling up with water, then turn my bilge pump on. So you simply put a not and you can read it like that. If this is happening, so if the number is greater than 1 and the button is not pressed, turn the bilge pump on. If the button's pressed, this will not be true and this will not happen. You could also use a nor, but I just like to keep it simple personally with and not, because then when I go and track everything like this, I can clearly see what's going on. Composite. I did say I was going to touch on the composites. This is not a tutorial for composites. They are a little more intricate, but pretty much with composites, you have to consider you have a bunch of channels at your disposal, and you can use them for the on-offs, you can use them for numbers. You can assign channels to them, and you have to read them and send them. So it's not just a simple one. Most likely you'll want to have a composite output that is able to receive said composite. Now that probably confused you more than not, but in essence, what you'll want to do is read up specifically on composites. This simple function, you can trigger, for example, a light, just like this. And this, you can trigger a number, just like this. If you've set an instrument panel to these channels, this is basically what you do here. Whereas these ones are feeding from a number, call it a sensor, and pushing it into this. That's all I'm going to go into. very, very broad, basic overview, but in essence, Composite is a little bit more complex. But their biggest advantage, you can send multiple signals through one wire. So whether it's a cable in the game or one node can handle many points of data. Now I talked about debugging and using these tooltip numbers and tooltip on off. I did talk about the property slider. Remember how I talked about property slider? Well, there's actually a on-off equivalent of that too, where you can set toggle on off, and out here you can do that. So that's quite neat to note. What I do want to mention are some efficiencies, some tips that can hopefully help you. If you're just starting off in the game, I urge you to keep your style consistent. This, what you see in front of you, is pretty much my style. I like to kind of stack things on top, keep almost columns of data, as you can see here. And it just helps me understand my things. Now, if I open up someone else's microcontrollers, it may look nothing like mine, and I'll be lost, but at least your own, you're good to try to understand and realize what is going on within it. Another thing I urge you to do is make your microcontroller in one go. If you're making something complex, for example, my elevator microcontroller, in here, it looks insane. It looks way too crazy, but it's not actually crazy. What it is this code here repeated 4 or 5 times down there, and then there's 3 buttons. You can see 1, 2, 3. They're continuously applying to any of these OR functions here. So, and then it's going to this. So if I try to diagnose this now or dissect it now, good luck. I'll be lost. I'll probably have to spend a good 20 minutes just understanding what is going on. But you can see I've kind of kept my columns. So you can see the data, how it transfers. You can see that here are the SR latches. And not only that, what's really neat is I made this in one go. I didn't take a 3-day break in between, because you take a day break, it's gone. So I'd urge you to try to make things in one sitting and then make revisions after the fact, because revisions, say you test it and you find it's not stopping on floor 3 in my elevator case. Well, I can find, okay, well, floor 3, oh, here's floor 3 or 4th floor or whatever. And now it's not working and I could find it. But if you're trying to link all of these and all of these, you're going to be lost if you do it in multiple goes. So I highly recommend you do that. Another thing I highly recommend, your naming system. This is critical. As you can see, my ECU has multiple versions. Now, before I started really paying attention to this, I have stuff like this. This is no good. Recently, I've been labeling them V1, V1.1, and what you'll find, you can't have periods, so you have to just put a space, but within here, I've actually labeled it like this, V1.1 with the period. I always just take this, copy it, and go here, save, and then move my cursor over one left, add a space, boom, save. So if I press this, it's going to say, do you want to overwrite? For me, because this is my system. I always use this, and it allows me to quickly find my microcontrollers and the version. So for example, my cars are on version 11 ECU. If I find a car that has version 6, I know it's outdated. Now, another thing you may have noted is here, I always put my name, and here I say what this version is. Because if I open up the previous one, you could see in this one I added drive, reverse, park with space key. So any previous versions that weren't V1, and most likely they're just going to be this because that's when I changed my sequencing, it's not going to be any good. And I've done this for everything now. I highly, highly, highly recommend you do it. You could see here V1.2 with Unicon switch channels. So labeling them with a version, explaining what you did, because here's the thing. If you're trying to find, say version 1.3 broke. So I wanted to go to version 1.2. Well, I can see what I'm missing. So in this case, I added time estimate hold heading. So I'd have to go to V1.2 and add these things because now it's no longer working. Another little tidbit is to use, for things that are complex like this, use text. So you can see down here, we have a property dropdown, property number, but if we keep going, we get to property text. It lets you to add custom text. So what I can do is go here and say, put this on the elevator bell. And that will now go next to this. Now, of course, this is labeled elevator bell, so that's really unnecessary, but you can label things within your microcontrollers. So in the future, if you or if a friend or someone is trying to understand what's going on, you can make it very clear. So for example, just very randomly, but let's say this constant number here in this is like triggers elevator lock. And there's no way for you to realize that these numbers or sequence of code triggers the elevator lock, but here you have a text and that explains it. The last thing I didn't cover are timers. Now we have 4 timers. 2 of them are similar and 2 other 2 are similar. The only difference is that you have ones that have resets and you have ones that don't have resets. So if I put them all here, you'll see the difference between the 4 of them. These 2 look similar, these 2 look similar. Well, these 2 behave similar, these 2 behave similar. And the difference in their behavior is such. I don't have them memorized, by the way, like RTF, RTO, but in essence, what you want to know is that there's one that outputs an on when the timer is less than its duration. So if you set a timer for 10 seconds, it'll be on for 10 seconds and then off once it hits that point. The opposite one is it outputs an on signal when the timer reaches the duration. So if you have it set for 10 seconds, it will not be on until it hits 0 and then it turns on. So they're opposite. Now the difference between these ones are they're the exact same thing minus that reset button. So you don't have a reset button. Here you can stop it in essence or reset it. Whereas in this instant, it happens only once. And if you never reset this, it'll never happen again. In the case of the ones without the reset button, it'll happen as many times forever, as long as it hits 0. And then as it hits 0, this will be resetted. The duration you can set with a constant number, or you can set it with a slider like I showed you, or a property number, or whatever you want. Even a keypad can go into there. Obviously timer enable and timer complete turns it on, or whatever it does. So that's pretty much it. What you'll note is that once you get familiar and keep doing it more and more, you're going to get more comfortable. So yes, it is easy just to stick with the logic boxes that I showed in the beginning, but the more you do this, trust me, the better your creations are going to be. So I highly recommend that. Anyway, thank you for listening along. This is Microcontrollers 101, the very, very basic microcontroller information you have to know just to begin, just to scratch the surface. I do want to thank my Discord server boosters and my YouTube members. I'm actually working on getting special perks to each one of these special members, or premium supporters, I'm going to call them. And I do want to thank each and every one of them because they're going the extra mile and supporting what I do. So hopefully learn something. Stay tuned for more videos. Like I mentioned in this one, I'm going to make detailed videos explaining other things. Stay tuned for more creations. And as always, happy Stormworksing. See you next time.